Okay, welcome everyone to yet another tantalizing episode of Handmade Hero, the show where we code a complete game live on stream. I have to tell you that immediately after the stream ended on Friday, everyone wrote in to say that there was a typo in the code, and so, well, we're not going to get a chance to watch me find the typo because basically, it was a total spoiler alert situation. Now I know that there's a typo in the code. I don't have to go doing any debugging to find it. So we're going to start off the episode today just magically knowing that there's a bug because literally everyone saw it. I suppose that's one of the bonuses of doing programming on stream is, yes, your mental energy is diverted because you're talking all the time, but you get this special bonus of everyone's looking at your code as you're typing it in. So if there is an obvious mistake, it's highly unlikely that it's going to go unnoticed by 2,000 eyes, or I don't know how many people. I don't know how many people actually watched that episode already. Yeah. So when you get that many eyes on it, I suppose you've got a pretty big bonus there. All right. So let's get started, because really all we were going to do today anyway is debug it. So we've got one bug we know we can fix, and then we can start taking a look at other bugs. And if we run out of bugs to fix in the short term, then obviously we have to move on to getting rid of the n-squared part of our algorithm, because that's going to cause us problems for, obvious reasons. Anyway, let's go ahead and open up here. We are on day 307. So if you want to follow along at home, you want to unpack day 306's source code. That's the source code state that we're starting with. You can see, let me just, before I actually go show you what the typo is that people had reported, which it was sloppy of me to leave. Let's see where we're at here. Okay, so it's a little bit hard to see here. You can see there's a little bit of the rectangle problem, but the problem's a little bit more noticeable if I actually turn on. Let me just go back to the state that things were in before I started simplifying it down to look for the bug, just so you can kind of get a feel for how bad the bug was, or how bad the sort was doing before we do any of these bug fixes. So you can have like a baseline, if you will. All right. So in add standard room, we kind of removed all of the room tiles, right? We sort of if zeroed out this else clause. So if I go ahead and put that back in, that'll certainly add a ton of stuff back into the game. So here is here is one room's worth, and you can already see that the room is sorted wrong. So I'm going behind these things, and again, we don't actually know in some cases how wrong the sort is because we're not feeding it exactly correct values yet. So there are some cases with that, but you can tell that, it's pretty bad, right? The trees are wrong and blah, 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 right? So even with just one room, never mind a room stacked on top of it, you can see a lot of problems. Okay, so what was the typo? Well, the typo was just that when we were in the render group code, and I switched things from rect min max, I forgot to switch the push rect min max, right? And I don't know if you remember back to the time when we did this, but I had done it with rect min max, and I was like, oh, we have a rect min dim, we should use that. And I changed one of them, but I didn't change the other one. So we still have a rect min dim here, a rect min max where we should have had a rect min dim, and so obviously that makes the rectangle completely nonsensical. So in fact, presumably that made most of them have no area as well. They would be inverted because probably the basis P would be further away on the screen than the scale dim, which is going to be down in the corner because it's a small, it's going to be a small number. So if you set that as the max, it's going to be probably a rectangle that has negative area, which is not going to intersect anything ever, and hence not participate in the sort, probably, or maybe does weird things. I'm not sure. We haven't really looked at what the ramifications of that would have been, right? Okay, so here is the version of the code running without the typo, and it looks to me like, certainly there's some improvements here. Obviously these pieces are sorting properly. The steps are sorting properly. But there's still some weirdness to it that I don't necessarily know if I completely would understand immediately, and I don't know, and would indicate to me that maybe there's a little bit of bugginess there, and other parts which maybe don't. So let's take those one at a time. So the first thing that I'll point out is, the heroes sorting incorrectly. It doesn't really bother me because we haven't really done much work yet to do how that's going to work. And furthermore, I don't anticipate that actually working the way that it's working now with the janky Z values, how we've got it. I actually figured now that we have a topological sort, we will just add things that's like the hero's head is on top of the hero's cape, the hero's cape is on top of the torso, and we'll just let it always sort properly since we now have the ability to mandate sort orders for things without having to touch Z values or anything else. So I think we'll want to build that into our system somehow. However, so that's one thing. So I'm not worried about that yet. It's not super concerning to me. And we've got the rest of these things here look kind of okay, but you can see that when I hop up on these, we get some sort of oddness happening there. I don't know that I care about that either, because that's the way those are being rendered right now is they're rectangles that are self-intersecting. They're in the same z-plane and self-intersecting. That's not a case I necessarily care about handling at all anyway, because that really shouldn't be happening. I don't want that to be occurring in the actual game anyway, so that's also not a problem. But what does concern me is over here. If you take a look at the left side of the screen, you can see that the trees, although everywhere else the trees appear to be sorting properly, you can see that the trees on the left side of the screen do not appear to be sorting properly, to me anyway, right? Looking at those, the trees, all these trees at the top, I guess I don't have a mouse cursor at the moment. Why don't I have a mouse cursor? Are we not in Handmade? Oh, right, because we turned off the debug stuff. Let's turn that back on. We don't actually know what that's going to do we? Code, build. Handmade internal is off at the moment. Let's turn it back on. When we did begin render group, we decided that needed to change to have the, what's that thing called? The, well, I can't remember. We decided to change that, so that it would take the height of the screen rather than having that come down in the perspective transform or the orthographic transform. So basically, these two parameters here, they just hopped up to they just hopped up to the call where we create the render group. So that's pretty easy change. Otherwise, looks like we got no problems re-enabling that. So let's take a look at what's happening there. Okay. So there we go. We can see that this is still incorrect, right? Like that should, I believe those are Z sprites or should be Z sprites. I guess we can verify that they actually are coming through as Z sprites, but you can see that they're not sorting properly, even though I believe those should have a very high Z value, right? Like those should be things with Z values that are always going to compare on top because they should be extremely large Z values, I think. So I'm not sure what's going on there either. And you can also see furthermore that when that turns on, you can see that I get proper sorting for all the things that it overlaps. So it almost implies to me that like these trees are not actually sorting against each other, right? Okay. So what all that sort of adds up to for me is I would like to augment our ability to see how the sort is behaving. So really, although it was nice to have people catch the typo, I think the sort of path I'm going to go down this week for getting the sort stable and doing what we want it to do is really going to be the same as if I hadn't been told about that typo. So if we still had the typo and had to find it, I'm going to do exactly the same thing. And what that is try to add some sort of visualization to the system such that I can see, A, what the screen space bounds of various sprites are, because right now I have no idea, right? Like right now, I'm looking at this screen, I have no idea what the bounds are for those trees. They could be completely wrong. You know what I'm saying? They could be just completely erroneous. And I suspect that what we'll find is they are. And remember, part of that's because we're not sending down the correct... we don't actually try to look at the scaling of things or, you know, necessarily if the X and Y axes are different or blah, blah, blah. Right? So I think what we want to do here is go, okay, let's make something that operates in the renderer that can draw what the bounds are of our sprites so we can see. And then maybe also, if we're lucky, we could add something to that system such that when it is drawing those boundaries, it's also going to be able to show us what the groups are that were sorted together. So for example, all of these trees going up the left-hand side of the screen should form a coherent sort group, right? Because the one at the bottom needs to know that it's in front of the one that's right above it, and so on and so forth, though I can point with my mouse pointing it. So like this tree needs to be sorted against this one, which needs to be sorted against this one, blah, 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 all the way up, right? So all of those guys have to form a coherent sort group in order to be sorted properly. If there's a break in that chain, if for some reason it doesn't think that those sprites are in the same sort group, we have a bug. We'll never know that we have that bug other than seeing incorrect sort, the results. We'll never know that that's a type of bug we have if we don't have some way of seeing what the sort groups are, right? We wouldn't know whether that's, you know, part of the bug or whether it's some other thing that's happening in the system that has nothing to do with producing what the sort groups actually are, right? So that's where I would like to go with it. So the first thing I'm going to do is I'm going to start by turning off some of the entity highlighting because we've got a little bit too much of that going on right now, and so I want to eliminate some of that. And I think we can also eliminate some of the gratuitous rect outline stuff that's happening at the moment. Because, you know, it doesn't really need to, some of it does not really need to be there. Like, so for example, I would like to, where are we? We're in world mode right here. Default flat transform. So all of those are fine. I'm going to go into entity. I think that probably most of them are in here. Yeah. So I'm going to take the volume highlighting out so that we don't highlight any collision volumes at the moment. And I'm also going to take out the rect outline from the traversables. I don't actually know that that one ever needs to be there anymore. That one might be one that we can just kill entirely. But that way we'll have a lot less stuff on the screen that looks like rectangular pieces, right? So now we can sort of hop around and it's all fine. You also notice the speed has increased quite a bit. And of course the reason for that is the less of those you have, the less sort groups they sort of form probably. And the less n-squared sorting stuff has to happen, blah, 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 blah. I mean, who knows, though? That's purely speculation. So anyway, if we look at the situation as it stands now, what I should be able to do, and you know what's actually, what's kind of interesting about that, is if you look at what happened there, removing those made these sort properly, somehow, which is kind of odd. I'm not sure what to make of that exactly. I say. That seems a bit odd because I'm not sure why that would have had all that much of a impact on things. Like if you look at how that goes, and what happens if I move my selection cursor down? That's very odd. So merely the act of adding a few Z sprites in that are kind of stratified there immediately caused a problem where the sort order was determined differently than it would have been if there's only one flat Z sprite. Because there's obviously always a flat Z sprite spanning there. So I'm kind of, that's very strange. I'm not sure why that's happening. I might want to gather a little more data here. I might want to add a room on top just to see what happens with those sprites. And we'll get rid of it in a second, but I want to take a quick look at what's happening there. So that's going to be add standard room. Oops. That's going to be add standard room, and I'm just going to say, okay, let's push one more room on top there and see what we see. So yeah, so that, you can see that sort is just wrong. Let me kind of move up here. So you can see that like some of them are on top and some of them are below. So I feel like we've still got some pretty fundamental problems happening on there. So that's good. That means I don't necessarily have to have anything all that much like the those little bars in there, although I could put them back in if I want to spurn that bug. All right, so I'm going to start by going into the renderer. And I guess I'll do this in the OpenGL renderer since that's the one we use most of the time now. So what's going to happen here inside this renderer is I'm going to need some way of rendering what the sort groups were and what the sprite bounds were and that sort of stuff. Now, thankfully, the sprite bounds are ordered in the same way that, like, we can index into the sprite bounds using the same indices that we index into everything else, I believe. At least I'm pretty sure. Although now that I think about it, I guess we don't really even need to do that, now that I think about it. Really, all I have to do is just add a pass here. After I draw all these things, do another pass where I draw all of the sprite bounds, right? Because I have the list of sprite bounds and I can draw them, there's no real impediment to me doing so. So what I could do is say, all right, here's the thing that lets me get that array started, right? And then I can just loop through these as I go. So I'm just going to say, for each of the bounds, there we go. I'm going to say sort sprite bound, bound equals entries plus bound index, and maybe I'll call that bounds. For each of these bounds, I have information about what is in the bound, right? So if I go to render.h, you can see that I've got this sort sprite bound. I've got a bunch of information about the edges here. These sprite edges tell me, who's in front and who's behind of each one and all these other sorts of things. And those are indices into the sprite bound array. So I think I could draw a fair bit of information, certainly. And I could also have, in here where we've got the visited and sort of drawn thing, I could add another thing that's like sprite debug box or something. And I could use that to do, if I wanted to, a sort of a similarly recursive bounds drawing sort of thing, where I sort of show like paths among different connected groups, if that makes sense. So yeah, I think I should be able to do this relatively straightforward, I think. All I really have to do here is say, well, all right, let's go ahead and do a draw bounds recursive on this, and I'll pass the bound. And I probably should call this something so I can tell what that it's an OpenGL call, right? So I do OpenGL draw bounds recursive. I say here's the bound, and I probably I don't know this because of the way we were doing it before. I'm just kind of thinking maybe the easiest way to do it is to pass that bound index as well. So if I come up to here to draw bounds recursive. I'm guessing that the other thing that I'm going to want to do, and I'll just quickly put these in here. So here's sort sprite bound. And this is the bound index. So when I call this function, I can then quickly check in here if the bound flags and sprite debug box, it's the exact same kind of depth first traversal we were doing before. I can do that, and then I can say, well, as soon as I check one of the bounds, I'm going to OR in the debug box flag so I know I won't ever draw this guy again. I can then loop through, just as I was looping through before, all of the sprite edges. So I can say, like, okay, for each of the edges coming off of this, what is it, next with the next edge with same front. For each of the edges coming off of this node, I'm going to walk backwards to that node. So I can just say, like, okay, OpenGL draw bounds recursive, bounds and edge. I'm going to go with behind because that's the order we walk in, from front to behind. And now I've got a thing that will crawl those. Now what I'd like to do here is I would like to draw a couple different things. First of all, I'd like to draw the screen area. Because obviously the screen area is the thing that lets me see kind of what we specified as the bounds for a particular sprite. And then I'd also like to draw perhaps an edge between, like a line, but to connect the centers maybe of those boxes. I also feel like I would do myself a favor visualization-wise if I go ahead and say, hey, draw all the connected groups in the same color. So I'm going to do a thing here where I also say, v4 color, right? Now, I feel like we had a thing in debug where we had a color table, right? Here's that debug color table. And I feel like maybe the debug color table is something we want to just kind of have as a systemic thing so other people can use it as well. And so, if I'm not sure where to put that exactly, but, let's just say that everyone gets a copy of the debug color table. If you ever want to use it, it's there. Don't worry about it. It's all fine, right? So let's say we pass in a color here. Then I've got some options for how I want to draw these things. I want to draw some lines here, so I think what we'll do is say this is all going to be done with lines, and then I can just do one big start and end block for each individual recursive call. So here's how I'm planning to make that work, right? I'm going to go through each bound, and for each bound I'm going to start with a different color, right? And obviously I don't really know what's going to happen with these colors as they loop. We don't have necessarily enough colors to ensure that every group is a separate color, unfortunately. So there's really not much I can do about that. We'll have to let the line connectors sort of clue us in as to that as much as possible. But what I don't want to do here is I don't want to create a new group for every bound index because a lot of those bound indices are already going to have been used. So what I think I'm going to do is I'm going to do an early check. And hopefully this makes sense to you as I'm saying it. If the bound flags and if the bound flags are not set for that guidance, that reminds me, I missed it here. There we go. If the bound flags are not set, then we're going to actually do the call. And the reason I care about that is I'm going to start the GL. I'm going to start up the GL stuff for the drawing and set the color only on ones where I know that I'm going to draw it. That way we don't use up colors in the color table unnecessarily and possibly get fewer actual distinct color regions than we should simply because we are cycling it based on the bound index, which is not actually representative of when we're actually drawing a new group. So what I want to do here is say like group index equals 0. Inside here we'll increment the group index, and then I will use the debug color table by taking group index instead, right? There we go. I think I can do this right. So this will basically say, get us a color out of the debug table, every time we need a new group. Go ahead and start a group of lines, call the recursive bounds drawing, and then end the set. Sort sprite bound is an undeclared identifier. Is that so? What? How is that the case? So these, I thought these guys were operating on these in this, I guess we're, what? I'm confused. So you're telling me Handmade OpenGL doesn't include sort sprite bound? Is that true? You seem to think it is. All right. Well, I'll take your word for it. And you're right. You are correct, sir. Let's see here. So it looks like the problem is we kind of have a sort order problem there because loaded bitmap is going to be in the wrong place for that. Yeah, so maybe something more like that. There we go. I hate this aspect of C++. It is so annoying. Okay. Function does not take 2 arguments. That's true. Got to pass that color through. Although actually, now that I think about it, we don't have to pass the color at all, do we? Because if it's just set in OpenGL and we're all just drawing lines, then everything's fine. Get sort entries identifier not found. That probably just needs to be forward declared. Get sort entries. Bloop. Bloop. And by the way, these are done, right? These are not, temp memory size isn't being used anymore. All right, let's see. We need to pass directly the float pointer there. So there we go. So we're passing that color to OpenGL, then we're drawing a bunch of lines. Now this shouldn't do anything yet because we haven't actually issued those line directives. So we should just see what we normally see, which is good. Nothing, no surprise there. But now we want to start actually drawing those lines. And you already remember how to draw in OpenGL, right? When you start a primitive type, like triangles, right? Then we set, we just set what our vertex pointers are going to be. Now, when we draw these lines, we're going to have a problem with texturing, because presumably texturing will still be on, because I think that's our default state, is to have texturing usually stay on. There's texture 2D. So what we need to do when we come down here, we're going to have to disable texturing, because we don't want our lines to pick up any texture that may have been set. So we need to make sure that that's okay. All right. So then when we do our OpenGL rendering here, all we have to do is retire some actual vertices to draw a line. Now, there's a couple different kinds of lines that we want to draw here, right? One is we want to draw like a line from us to our sort neighbors, right? So I guess I'll just call this neighbor or something. And that's just going to be bound plus this behind edge. And I guess, you know what else? I could just call this behind. So if I have 2 of these things, and I want to draw a line to the one that I'm, that's behind me, what I can do there is I know what the screen space bounds of these things actually are already. That's going to be specified in here. And what that entails right here is just getting the center, I guess, of that, or however, I assume I want to draw to the center, just getting the center of both of those and then drawing between them. So I just have to know, like, what is my center, and I can do that, I think, by just saying get center, because I believe we already implemented that function. If not, we can go do it on rectangles. So there's the screen area. And then I need to do the behind center, which is the, one for the one we're drawing to. Same exact thing. So now I've got 2 points that I can draw between. So if I want to draw a line, after I do the recursive part, I'll do it, I'm not sure when I should do it, really. I guess I want to do it, well, they're all the same color. So I guess it doesn't matter, because they're all just going to fill pixels, so it doesn't really matter when I do it. But I guess I just want to now say, okay, let's retire 2 vertices, one on either side of the, one for each of them, right? So I've got the center, and then I've got the center of the one that I'm, the one that's in front, and then the one that's behind. Then after that's done, I can also draw a rectangle, right? Where we say we've got the screen area and we've got the min and max of that. So what I could do here is say like, you know, what's my min, my, I don't know, screen min, something like this? Smin. So I could say, okay, give me the min of this and give me the max of this. And then I just need to draw, you know, the vertices of the rectangle around. And I think we have OpenGL rectangle, and then we could do another one here that's like, you know, something like line vertices or something like this. OpenGL line vertices. And really that's just saying this exact same sort of thing, only instead of doing the triangles for a solid rectangle, I'm just going to go around the perimeter, right? So I'm going to start with the min. And I'm going to draw from the min to the max in X. And I'm going to go, you know, counterclockwise around. Then that's one line. Then I need to start there, right, and then draw up to the max. So I'm going up the side of it. Then I need to start there and go back along X, but staying up at Y. And then I need to start there and go down the side. And that's all of the vertices in that rectangle, right? One, you know, 4 lines, one for each side of it. So there I can just say like, okay, you know, output the vertices for this line, for this rectangle, and we're good. So hopefully, oops, and that's a bound screen area. So hopefully that's good. It looks like getMin is not in there. Min corner. Don't ask me why we thought we needed a corner in there, but I guess we did. And so now hopefully we'll see something. There we go. And, you know, some of that looks kind of right, and a lot of it just doesn't look right at all, right? And so already we can tell there's bad news happening here, right? Like, there's some people whose screen areas is just garbage or something. Because some of it, like if you look at the region of the hero, it looks really pretty good, right? It looks relatively correct. And of course, there's some issues there because we're not scaling things right. But you can see the lines are connecting it to the things that it's over, and that all feels kind of right. But then we've got these problems of these other rectangles where everything's sorting against, and I'm not sure how right that is. Now, part of it might be right because it might be looking at a solid filled rectangle, like let's say the clear screen. You know what I'm saying? If all of those are just going back to the clear screen, then that's not really a problem. And now that I think about it, that's probably what that is. I'm going to take the clear screen out for a second and see if that's the case. Okay, so that's good. That's, you know, that's pleasant. So now we know that really that's just the clear, and it's the clear that's sort of making everything end up forming into one giant group, right? So that's a happy thing. Okay, and that's looking pretty good in terms of detection there. You know, that's looking relatively sane. And I don't really want the clear to be doing what it's doing. I don't know that that's a particularly useful thing for us to be worrying about. Is having this giant thing that will unify. Because if you think about what happens, is if we leave the clear in there, it means that everyone will always be part of one single giant group. You know, it's just a given because there's one thing that covers the entire screen. Everyone's going to get sorted as part of that group. And there's no need for that to happen because we know that the clear happens at the outset anyway, right? So the clear doesn't really need to be in the sort in the same way as everything else does. And the only real question I have about that is what's the right way to slipstream that into the process, right? Because, you know, we could do the most straightforward thing, which is to just have the clear be something that's, you know, you just set what the clear color is and then it happens automatically. And I don't know, maybe that's a good idea. The reason that I hesitate to use that as a solution, even though it's you know, it's relatively reasonable. The reason that I hesitate to do that is simply because we don't really know how the pipeline is going to expand. We may have to clear like other surfaces and stuff like that. But I guess what we could do is just say that we're never going to really be clearing. Handmade Hero is not the type of game where we're going to be clearing stuff that has content in it ever. We're only clearing on start. So I guess it would be fine for us to just say, well, when that day comes, we're going to have another thing where we say we want a render target, and when we want a render target, we could always just say what the clear color is. So I suspect we could just say, without really much loss of generality, or really anything, that just the clear is something we'll manage separately. And typically there really isn't any reason to clear anyway, so it's not even something that really needs to be in here. We could just bake it in to the program in general. So yeah, you know, what we could say something like in Handmade OpenGL, you know, if it's Handmade internal, we clear. Or better yet, I think maybe in here, what we would do is say, well, GL clear color, and we could get our hideous pink on. We could do that and then just leave the clears off. And, you know, do we want to maybe re-enable them in the future? I don't know. But we could just say, all right, you know, that's how it goes. Because pretty soon we're going to be putting in real ground tiles, and then we want to see anywhere that for some reason we're not drawing. You know what I mean? Although really I think we said we might want to do fogging with that as well. So I don't know. We'll have to cross that bridge when we come to it. I'm not sure how we're going to want to draw some of that stuff. So we may have to have control over the clear color. And, you know, that's fine if we do. All right. So yeah, what I could do there is just say, I'm trying to think of what the easiest way to do that would be. I guess, you know, what we could do is say, well, all right, let's say that in the platform system here, let's say that in addition to what we're sort of passing through, let's see, where are we? Not the platform API. I just want the game render commands. I'm just going to say, like, all right, so let's say that in here, in addition to this stuff, we're also going to have a clear color. And so that way it can look in OpenGL, it can say, oh, well, the clear color is just going to be whatever they said it was. Right? And then we can just say, yeah, you know what, the render entry type clear is not going to be a thing. We're going to get rid of that. And when we do our clear here, we're going to pick up whatever was in was in those commands. So, we can decide what we want to do with it later just fine, but then when we actually go to issue a clear command, instead of pushing something on here, we'll get rid of that. Instead of pushing something on, when we try to do that instead, we'll just set the commands, right? So when we do our store color here, instead we'll just make that be a thing where we don't have to do any of this. It would also get us out of the business of storing that screen area. I want to keep that screen area in there for other reasons, I think, so I'm not going to back that out. But we could now if we wanted to. So the clear, oops. Absent-minded typing. So the clear now does what I want it to do now. We've got to get rid of these. And what I'll say here is I'll just elevate this draw rectangle call up to where we were doing the clear in the previous case, right? And then when we, I'll just grab whatever that command's clear color is here and let that happen. And then I will delete that from the software renderer so it will still be compliant as well. All right. Initializing conversion from something to something else. U32 to real 32. Ah, that's true. So in this case, we need to do render command struct. So in here, we want to clear the clear, if you will. So after the push buffer, max push buffer size, and the push buffer base, where we're going to do the element count and the sort entry size. In here, we just need something that's going to initialize the clear color to, black or who knows what. Okay, so let's see what happens now if we get setting of the clear color. We do. So that's all. That feature is now restored. And now we're sorting the way that I had hoped we would sort in actual local groups. And yeah, that's really all there is to that. Yeah. So it would be nice to perhaps to have things that sort of exist outside of the sort thing. We'll sort of get into that, I guess, in a little bit. But let's try turning on some more rooms now and turning off. Let's first turn off the debug and see where we're at in terms of sort behavior. Now that we've got that single sort, because I suspect that was creating a lot more cycles and things that are difficult to break. And so, we were probably getting worse performance out of the sort than we thought we were going to. So anyway, let's go ahead and switch back. Out of here. And we can also have a thing that's like if, show sort groups or something like this. And I guess, well, you know what? We do have this whole ridiculous thing. So we could do a global variable b32 global show sort groups. And then, I'll be honest with you, I don't even remember how that system works at all. But we should be able to do something where we can just put that if in here. And then that can get enabled, I think. Oh, you know what? Except it's in the platform layer. How does the platform layer deal with that? I don't remember. Global pause. Here we go. So here's the platform controls, and we have like these two. So I want another one, which is, global show sort groups. And then I can just put it up here. So in theory, of course I have to actually recompile it, but in theory, I guess that would let me toggle them on and off, except that's still wrong. But it does work. So that's good. Okay. All right. So we're starting to get there, and if we turn it off, we can see that the sort now appears to be working at least more correctly, right? If not correctly. But we have this problem here, and also we don't know what happens if we add, like that's not much of a test, really. If we go in here and add the sort of much more heinous cases here of having more than one room on top of each other, we get a better idea of just how far we are from having all of our sort dreams fulfilled. Let me go ahead and hop up here. So, it's not bad, but you can see it's not really correct. There's still a bunch of problems there. So I suspect that we will probably have to do some looking now at our sort criteria. And then we will also have to look at the sort cycles. So I think what I'd like to do now is take a look and see if we can't draw an indicator that lets us know when we have cycle problems, right? Now, I'm going to flip back to Milton for a second here on the blackboard to just remind you of what this is, because I talked about them, but then we haven't actually dealt with them yet. Because this is another problem. There's essentially two sources, well, three, I guess, sources of error. I might as well write these out while I'm on the blackboard. There are three sources of error for our sort. Okay, so what are our sort error sources? Well, one is just bugs, right? One is everything that we talked about and said and did is correct theoretically, but we made a mistake in the implementation, right? Like the typo that we fixed at the beginning of the stream, for example. Okay, so that's one source of error. Another source of error is like bad comparison. Because remember, we're using an ad hoc sorting criteria that we kind of made up about Y sprites and Z sprites and how we sort the two of them together. And we haven't really ever determined that that's actually a comparison that's going to work for everything that we need it to work for. And so we may have cases where actually the problem has nothing to do with the fact that we've got a bug. It's because the comparison is operating exactly correctly and the algorithm's operating correctly, but the comparison is just fundamentally theoretically unsound. And we know that we could construct cases for that because we're inherently doing a sort of hand-wavy kind of sort since we're in 2D and we're representing full 3D objects with complex sort of interrelations with just 2D cards. And those cards can't capture the real relationship between these objects that are actually supposed to be volumes, right? So we've got that. And then the final one is, graph cycle resolution. And by resolution, I mean the act of resolving, like resolve the cycle, not resolution like how many pixels something is, right? And so what I mean by graph cycle resolution is we know that we can end up with things with a topological sort like this that was sort of in the diagram shape that I drew up above. It can be much more complicated than this, certainly, but the most simple kind of a cycle, right, is I've got a few elements and they point in a ring. And what that means is there is no way to actually correctly sort these objects. There's no, the sort criteria doesn't yield a single ordering. It could be that we have some of those that if we, that the comparison, although that obviously part of that is that means the comparison isn't great, right? Because we've created a thing where it can't really tell us what order to draw things in. That's obviously not great. But it could be that if we had a more intelligent way of breaking the cycle, then the comparison would still be okay. So it might be that, for example, we're choosing to break the cycle here and draw ABC, but really what we should have done is broke the cycle here, right? And drawn BCA. And perhaps I should draw that a little bit differently. Instead of breaking the cycle here, we should have broken the cycle here, right? So BCA rather than ABC. And so who knows? That's, again, another place we could potentially fix the problem of bad sorting. Again, because there is probably no uber solution out there for us, since we are inherently doing a intractable problem. Underspecified problem, whatever you want to call it. We don't have the real 3D objects, so we can't do them with a Z buffer or something like this. All right, so that's the possible sources of problems. And so what I might want to do, and we've got about 5 minutes left here, so what I would like to do is maybe just go in real quickly and see if I can't, in the next 5 minutes, add something that will draw graph cycles for us. So it'll let us know if we have a graph cycle somewhere, that'll become clear. And so the way I could do that is I could say, well, if we go over to where we're doing our sorting, let's take a look at how this algorithm works at the moment. So what you can see when we walk the sprite graph is that what we're doing is every time we walk on a node, we set a sprite visited flag that lets us know that we shouldn't ever come back through here, like we've already used it. Now this is really handy, but what it means is we don't actually know whether if we were to traverse through this group, whether we would hit ourselves again, right? All we know is that somebody touched this at some point, but it could have been another traversal. So what we need to do here is we need to have a way of knowing that we hit it on our traversal, meaning we started somewhere, we went down a path, and we got back to part of our own path again. And if we see that, then we know we have a cycle. So how can I do that? Well, I've got two ways without really even modifying this algorithm pretty much at all. I can pretty much keep the exact same code, just change a little bit. There's two ways I can do that. And let me show you what each of them are, because they're both extremely simple to do. One way is to use a generation tag. Now you saw this already. We used it for asset tracking, where we essentially have a number, and that number increments, and we can use that number to see what pass through an algorithm something was done on. So right now we have a flag, we have a Boolean, right? 1 bit. That means that we have 1 bit we can set, and if we only have 1 bit that we can set, that means we can detect a cycle only in the grand scheme of things. We can only say, it's not even detecting a cycle, we can just say whether we visit it ever. But if instead we set a bunch of flags to 0, we set a generation tag to 0 at startup, and then every time through we set that tag to, if it was 0, we know we can process it. We set that tag to be equal to our generation, our time through the algorithm, right? So if we're on pass 3 or whatever, or pass 4, we set it to that tag. Then we would know, when we look at the tag, we not only know whether we visited, but we know if we visited on this time. Because if we visited at this time, its value will be equal to our value. Make sense? The other way we can do it is with an erasable tag. So we have a bit that says we have visited this thing. We need that bit to be permanent, right? Because if it's not permanent, then the next time someone comes through here, they're going to retraverse parts of the graph that were already traversed, and that's not what we want. We want them to just tie back into it, right? And say, oh, I know that that whole sort already happened, so just tie in here and be done with it, right? But what that means is we can never tell whether it was us who was traversing this or somebody else, because the flag could have been from some previous pass, some previous walk that started on some other sprite, not us. And that doesn't necessarily indicate a cycle. So what we could do instead is have another bit and say this bit we're going to set as we walk, and if we ever hit something with this bit, we know that we cycled. On the way back, we'll erase it. Since I already have a bit field, I'm just going to use that. So I'm just going to call this sprite cycle check. And then I'm also going to do something where we just do sprite cycle. So what we'll do is we'll use the cycle check flag to see whether we've got a cycle, and we'll use the sprite cycle flag to, well, you know what I'm just thinking? I guess we don't even need two of them. I guess we could just use one, probably. Well, we're out of time, so let me just quickly throw this in there, and then we'll worry about how we want to deal with it later. So when we step into this flag here, we would always do an OR in to put the cycle flag in when we traverse, and then when we come out of it after we've traversed the edges, we would just set it. We would just get rid of it, right? So we'd say set. Whoops. Where are you? Sprite cycle. There we go. We would just say, I want to AND with not the sprite cycle, right? So where is it? That is not what I'm looking for. There we go. Sorry, brain fart. I'm like, where is this? You know it's been a bad day when you don't know where the tilde key is. So anyway. So on the way in, we'll set it. On the way out, we will clear it. And what that means is that when we get to a particular node, right before we do anything else, we can do a check to say if the sprite cycle flag is set, then we know we have a cycle. Because it'll get cleared on the way out of a non-cycle one, and so we know that that's the case. So now what we need to do is have some way of telling that we've hit a cycle. And we already have this nice handy graph walk thing. So we can just have a thing that says, are we in a cycle or not? Right? So what I'm going to do is essentially poison any group that has a cycle with that cycle flag. And the way that I'm going to do that is say, okay, we're going to start with the walk. Every time we start the walk, we're going to say that we did not hit a cycle. And then every time through here, we're just going to say, okay, the walk's hit cycle equals the walk hit cycle, or the flags is set. So essentially, we come in here and we say, we know that walk hit cycle will be set to true if we've hit a cycle. And so I'm just going to say, and presumably that's, when we're calling down, that wouldn't necessarily be relevant anyway, but either way. We're then going to make sure that that propagates to everybody else so that we know that this is a group that has a cycle. So we're going to say, okay, if we hit a cycle or we're in a cycle, we are going to keep that flag through. We OR in the cycle flag regardless. And the question is, when we come back out, do we clear it? So I'm just going to say, if we haven't hit a cycle, we'll clear the flag on our exit, right? And that should leave us with groups that have cycles set if there was a cycle in them, so we can see it. Does that make sense? And that's really it. And so then if we want to draw those, and I'll turn this on by default. All we have to do is look for that flag and set the colors accordingly. So what I'm going to do is probably do something a little more drastic. When we do OpenGL draw bounds recursive here, probably what I'm going to do is say before we call that, let's actually just make it so that we'll only draw sets that have that. So we'll just put another thing in here that says, oh, by the way, if the flag and cycle isn't set, just don't draw it. So just only show me people who hit a cycle somewhere. So now, in theory, and of course there could be bugs galore in that, in theory I would see cycles if we had them, right? They would draw the outlines. And I don't see any right now, which means either we don't have any cycles or my algorithm doesn't work, right? So there we go. Seeing whether or not the algorithm works and debugging it will be tomorrow's job because we're out of time, but there you go. All right, so if you have questions, I may have answers. Okay, for those of you who did not see Insobot's amazing quote, I highly recommend checking it out. Anyone? Anyone? Abby, is that a question or a statement? That looks a lot like a statement. How do you decide when a problem is complex enough to need visualization? Well, the answer to that is usually you can tell that you're just having that. I suppose without some sense of intuition for it built up with experience, it's a little bit difficult. So I don't want to suggest that it's easy. It's probably not. But the general sense of it is pretty much any bug that you have or problem that you have, in your head, you've got some attack skills that you use to go after that bug, right? And typically what happens is you think about what the sorts of problems could be, and you think about what you would need to do to see if those problems existed, right? And so, for example, I'll take a very simple example that should hopefully be easy to relate to. For example, you might have some math code, and that math code might be doing something where certain values in the computation should be readily inspectable and easy to figure out if they're wrong, right? We've seen that on Handmade here a bunch. There's not a lot of need for visualization in that case because stepping through the code in the debugger is likely to yield the problem. There's not a lot of bookkeeping, and it's just one pass through some math and you can see what's happening fairly easily, right? However, other types of code have a lot to do with big pointery, structure-y things, right? Or relationships between like lots of different objects, this sort of stuff. And when I mean objects, I might mean like physical objects like in the game world. not objects like structures or something. In those cases, when you think about what the information is you need to verify, it's very hard to verify by hand. For example, if you were writing a binary tree and you're wondering why your binary tree code has bugs in it. Well, a binary tree might be 300 elements of things. It's hard to see what your algorithm's doing. All you see is a bunch of pointers, and you'd have to, like, on a piece of paper, like, write down what the pointers were and figure out who was pointing to who, and okay, was that rotation was supposed to move this thing over here? Did it do that right? And so when you start to get a lot of interrelated things happening over multiple functions, that tends to be the kind of thing where you need to do some sort of visualization work. Otherwise, it's just going to take too long to find the bugs. All right, programming questions. Let's see. Is the build graph still n squared? Yeah, we have not touched that. So if you look in here, inside sort entries, you will see that we have the build sprite graph and walk sprite graph code. The walk sprite graph code is ON, I believe. It's roughly 2n, I think, cost-wise. And then the build graph code is still n squared, right? Because you can see it. I mean, there's node index A, there's node index B. So, you know. It's a little less than 2. It's a little less than n squared, obviously, because it's like the n times n plus 1 over 2 or whatever. Because we don't have to consider the previous nodes, it's not really fully n squared, but it's still proportional to n squared. So it's still on squared, even though it's doing less than n squared actual things. It's still doing a number proportional to n squared. If that makes sense. Any other programming questions? Programming questions. I said programming questions. Questions that have nothing to do with programming are for the pre-stream. You guys know that. You know that's true. All right, I don't see any more programming questions, so I'm gonna wrap it up. I'm gonna wrap it up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. I think we made some good progress on the sort today. And so, yeah, I think maybe we'll have a good week. Hopefully we'll be able to... I think it's going to be hard work getting... Because anything like this that's kind of a nebulous algorithm that's hand-wavy, like 2D sprite sorting, it's definitely going to be the sort of thing where we sort a thing. Where we have to grind a little. But, I'm optimistic about it, and once it's done, it's done. So that's good, too. So I think we made some good progress, and we'll continue on that this week. Here is what I will say. If you want to follow along with the source code at home, you can always pre-order the game on handmadehero.org. It comes with the source code. There's a forum site you can go to if you want to ask questions. We have a Patreon page if you want to support our videos. Series, we have a schedule bot if you want to catch us live, and an episode guide if you want to catch up on past episodes. That is it for today. I will see you guys tomorrow, 8 p.m. Pacific Daylight Time. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.